Hi guys, welcome to the new tutorial on Java Multi-Threaded Programming 2. In this lesson, we will learn about Runnables, Callable, Future and ThreadPoolExecutor. We will set up Java Gradle project and we will use IntelliJ IDEA Community Edition IDE. We will design and build async model for user feed activity. We will learn through code implementation. Prerequisite for this tutorial is Java Basics and Java Lambda Basics. We will fetch the user activities like likes, post, comment and new friends added through different APIs and then merge those activities and sort them by the time created and then show the list to the user. In this part, we will set up our IDE and Java project so that we can develop our solution model. First thing we have to do is we have to install Gradle in our system. The link for installing Gradle is mentioned here. Second thing we have to do is we have to download IntelliJ IDEA Community Edition from JetBrains site. It's free. Next we have to create a directory MindDocs Multithreading 2, and in that directory we have to generate a Java library project using Gradle. Then we have to create an app with a main method in that library. So first link for downloading Gradle leads to the page where we have to download the Gradle based on the system you are working on. As my system is macOS, I will run this command brew install Gradle and it will bring the Gradle to my system. To download the IntelliJ IDEA, we will go to their website, click the download button and we have to download the community edition, which is free and open source. Now let's move on to creating the Java project using Gradle. Now we will open our terminal window and create a directory on our desktop called mkdir on the desktop on MindDocs Trading 2. Now it created our directory. I have to go to that directory and we will generate our Gradle Java library. Now it has generated our library. We can see the project here. We have to open that project in our IntelliJ IDEA. And open our generated project. Desktop MindDocs Multithreading to open. Just press OK with the default settings. Now we'll delete this library class and create our own new class called app. The app will define a public static main method void main, which takes string array as arguments and we'll print a message called program terminated. Okay. Now we'll select the app, right click it and run main method. Now we can see printed our program and then exit. In this part, we will observe our problem and then formulate a solution. So we are building a user feed with list of activities in the order they happened. Like, post, comment and new friends are fetched through separate web APIs concurrently. When all the APIs result, then they are merged in a single sorted by date list, and the result is then sent to the caller through callback. So this is the model which we need to program. So let's see the solution design. Like, post, comment and friend, they are fetched through APIs. So activity is an interface which all these four implements. This activity helps in creating a unified list of all the four types of activities. Executor helps in running the tasks parallelly and then bring back the result to the calling thread. Remote service is a central piece. It is responsible for making the API call to the server, using the executor to run the fetch task and then process the result once they are returned by the API. It then sorts the result and sends it via callback to the feed activity. So this is the solution model that we are proposing. Now we will see how to implement all these pieces of the solution. But first let's understand some of the things that make up the solution. So model building blocks that we will be developing will use Java util concurrent package, which provide the tools to build up this asynchronous model. We will be using ThreadPoolExecutor, Callable, Future and also Runnable. So what is a ThreadPoolExecutor? It implements executor service which defines various methods in order to handle the thread. And as the name suggests, it is based on thread pool. So it helps in using a fixed number of threads that is running the task, and then we use the thread when they are done with the assigned task. This reduces the thread creation overhead. So basically we are having fixed number of threads and we are using those threads to run multiple tasks. In order to create our thread pool executor with fixed number of threads in the pool, we will use a static method defined in the executor.newFixedThreadPool method. After we are done with the processing, we must call shutdown method of the executor service that will stop all the threads if anyone is running and also release the resources. Now let's see Callable. So Callable is an interface that is used to return the result from the executing thread back to the invoking thread. It has a method call and it is used to perform the task and then return the result or throw an exception. Callable task is run by the executor service by calling its submit method. If suppose we want to run a runnable through an executor service, we can also use execute method. Execute method will not return a response back to the invoking thread. Now let's see future. A callable task result is returned by future. We get the result from the future by calling it get method. The thread that calls the get method of the future waits till the result is returned by the callable after execution of its call method. So get method of the future is blocking, and the thread which calls the get is blocked till the future returns with a result. In this part, we will develop the basic structure of our program. So now let's open the project that we created in part 2 of this tutorial. So we have developed till here. We have created a class called app and defined a method called main. Now the problem that we are trying to solve has 4 parts: like, comment, post and friend. So we will call these as models. So let's create a package called model. First class that we will write is the activity. So create a new Java class called activity and make it an interface. Now this activity class will be implemented by all the 4 activities of the user. So it will be helpful in creating a list of all the 4 different types of activities. So for now we will define a method that will return date. So this will be the timestamp when the activity was done by the user. This will help in sorting the activity list. Next, we will define all the 4 types of activities. First activity is called like. So we'll create a class called like. It will implement our activity. Okay, so now this like will have a variable date called created at, and the constructor we will provide this created at field, and in get created at we will return this variable. Similarly, we will create other 4 classes. So this comment also does exactly the same. Then we have post, then we have friend. Now the comment, friend, like and post will have data corresponding to them, but for demo purpose I am treating that all of them has some value but not useful in this example. So we saw that we created an interface called activity, so which defines a method called get created at, and all the other classes implement this. Now we can create a list which will hold all these 4 different types of activities through the reference variable of an activity. Now we will define a class that will be responsible for thread creation and execution. We will call it remote service. Okay, and also the remote service will transfer the result back to the caller, which in our case will be our app, through a callback. Let's call it a result callback. Okay, so result callback will be an interface, and what it will return is void, will return nothing. On result, it will return a list of activity, call it activities. Okay, so this result callback is an interface. Whenever we supply this interface to remote service, it will pass on the result by calling on result method of this callback. So this is the basic structure of our program. The next part we will see how to implement thread creation by extending our class remote service. Now in this part we will implement the thread execution for our model. So for executing threads we have to create ThreadPoolExecutor. So first thing I will do is I will create a variable. I will make it static variable of type executor service, call it executor. Okay, and we will obtain an instance of ThreadPoolExecutor using static variable in executors. New fixed ThreadPoolExecutor. Now here I have created a static variable. So whenever this remote service class will load, this executor will get instantiated. Here I am creating a new ThreadPoolExecutor. I have called new fixed ThreadPoolExecutor method. So this will create a ThreadPoolExecutor which will have a fixed number of threads to run the task, and I retain the instance of the new ThreadPoolExecutor through executor service interface variable. Now next thing is that we have to pass the number of threads that we need for our service. So the rule of thumb is that in order to have an optimized number of threads, it should be one more than number of cores present in the system. So first I will do is I will ask from the system the number of cores it has. I will create another variable, will have number of cores. I will call runtime, get runtime dot available processes. So I'll pass number of cores plus 1. So I have one thread more than number of cores available in my system. Now when this executor is done with the processing, shutdown method should be called. So for that I will define a public method, call it stop, and this will shut down our executor. So now we have an executor and we can stop the executor. Now we have to get this executor running. So I will simulate the API call from the server. So for doing that I will create a method called getLikes, pass in the URL and then create a thread and wait the thread so that it appears that we are fetching the data from the server. So we'll create a private, a callable, it will return a callable because we have to pass the callable in the executor. So this will return a list of like. Okay, and I'll call it get likes method. Okay, I'll pass a string called URL. This is of no use for our example, but to simulate as if we're calling a server, I'm writing a variable called URL. Now this will return a callable. So I'm using a lambda to return a callable. Okay. So first thing what I will do is, when this method will be called, I will print it. I'll call get likes. So we know that get like has been called. Now I will make the thread sleep for, let's say, 2 seconds, and then I'll return an array of likes. Okay. So this arrays at list create a list of 2 likes. Now we'll have to pass the date. So pass the date. This will simulate the time at which this like has been created. Now let's provide a time which is different from the system time. So for that, let's find the current time in millis. Okay, copy this value. Okay, so let's change some of the values so that they will appear as if they have happened in different time. So this method getLike returns a callable whose call method, when is called, it will print get likes, then it will sleep for 2 seconds, and after 2 seconds it will return a list of likes, 2 likes with date that we have just changed. Similarly, we will write it for our other models. For the posts, return post. So this method will return 2 posts. Let's change the time. Similarly, we'll do it for comment and friend. Get comments, return comment. Okay, let's change time some more. Okay, similarly we'll write it for friends. Change some more time. Okay, so we have got our 4 methods that will simulate as if we are calling a server with a URL, and it will wait at random time. First we'll wait for 2000 milliseconds, that is 2 seconds. Second, let's wait it for 1 second. Third for 2.5 seconds, and third for, let's say, 800 milliseconds. Now we will expose a method to the service for the app to call in order to fetch all the activities, merge them, sort them, and then return. So let's call it get public void get user recent activities. Okay, and when the app calls get user recent activities of remote service, it will pass in a callback, result callback. Okay, so that after processing from background thread we could send the result back to the app. Now in the executor we will post a runnable. Okay, why I am using runnable here is that I don't want any result back to the calling thread. Instead I want that a thread of the executor should be used to run all these tasks in their separate thread and then finally send the result back through the callback. Okay, now we will create a holder for our various activities, call it likes. Okay, similarly we'll do it for post, for comment, for friend. Okay, so these are placeholders where we will store the values that will be passed on by the processing thread. We'll see in a moment how. So what we will do, we will call executor.submit and pass in the callable. So callable is that we have defined through our methods. So I'll call get likes, and for the purpose of demonstration I will write something like dummy.com/likes. Okay, so I'll submit a callable which is returned by getLikes method, and this submit will return a future that will hold the result that is passed by our callable. So it will hold a list of like. Okay, call it future likes. Okay, similarly we will submit three more tasks: get comments, get posts, get friends. It just changes for the demo purpose: comments, posts, friends, and this will return comment, this will return post, desktop post, this will return friend. Okay, change the comments, future posts, future friends. Okay, so when we submit a callable, a future is returned. So currently future holds nothing. Future will get a value once the callable after running returns the value. So this future is a placeholder where the value will be returned. After we call submit, a thread is from the pool is used and this callable starts to run. Now what I will do is I will get the values from this future. So I'll call likes equal future likes dot get. Now when I call get, now we have to handle the exception which can be thrown while running. Call try, okay, catch interrupted exception, execution exception, okay, mission is over. Similarly, we'll write it for future posts get comment, future comments on get, friends, future friends dot get. Now from all these 4 lists, I will create a unified list which I will supply to the app. I'll call list of activity, call it activities equals to new array list. Okay, so now in activities I'll add all likes. Similarly, we'll add all posts, all comments, I'll add all friends. Okay, now I'll sort it. For sorting I will use collection dot sort and I'll sort the activities, new comparator. Okay, now I'll replace it with lambda. Okay, this is called activity 1, this is activity 2. Now I'll call activity 1 dot get created at compared to activity 2 dot get created at. Okay, and now these activities are sorted by their date, and I will pass callback dot and I pass this result to the caller. So this completes our class. Let's review what we have done. We created an executor having number of threads 1 greater than number of cores the system has. We created a method stop so that we can stop the executor. Then we defined methods that simulate the API call, which returns a callable, and in the call method they wait for a particular time and then return a list with the values having different dates. We then created a method for an app to call, and it passed the callback through which we will notify the app. It creates a runnable and run it in a different thread. We create the placeholders for all the values. We submitted the calls for the API and it returned the future object. We call future.get, thread wait for the task to complete, and finally we gathered all the result from the server. All these 4 run asynchronously, parallelly. Then we accumulated all the values in a single list. This activity interface helped in creating a list which contain all the different types of activities. Then we sorted the activities by the time they were created and we returned that result through the callback. In last part, we implemented various methods of remote service. Now in this part we will use it. So open the app class and we will create an instance of our remote service. New remote service. Okay, we will call get user recent activities method supply in a callback. Okay, so when I call get user recent activities, the service will start a thread, and then that thread will start other threads that will fetch the activities, and finally the service will merge them and return through the callback we just supplied. So we'll get activities here. So now when I get activity, I just want to print them. Okay, so I'll call system.out.print a line and pass the activity. Okay, now when I'm calling print line for the activity, what I will do is for all the models I will override all the toString methods so that I can get a pretty print of this class. Similarly for the friend, so we get a pretty nice printing for the class. Similarly for the post also. Now when I call system.out.print, pass in the activity, it will call the toString method of all the models and it will print the values in a pretty manner. Okay, now here one thing that we can note is that when main thread calls get user activities, it does not wait here. It goes on and then finally terminates. So we have to keep the main thread alive while we are processing the request. In Android, main thread is kept alive by the OS itself. So what I will do is I will write another print where I will say program started. Okay, just to understand when it starts, and I'll create a flag that will keep the main thread running. Okay, atomic boolean I will use, call it processing. True. So now we'll call while processing.get, it will keep running. So when we get the callback and we printed out all the values, we will set the processing to false. Okay, now processing is being accessed by two threads. The callback is being returned by the thread which process them, and get method is being called by the main thread. So we have to use atomic boolean so that we can maintain synchronization between read-write operation of this boolean. So after processing is over, we will shut down the executor. Call executor service.stop. Okay, now since we got all the activities and we want to access post, comment and friend, we can use instance of to cast them into their respective classes. So now when we analyze, we see we called the method get user recent activities. It returns the activity list by processing the request in their own threads, and we kept the main thread alive till we are processing. After processing is over, we stop the service and then our main thread stops. So this completes the example where we have developed our model of asynchronous operation So we can utilize this process to design our system for various use cases that may arise in our programming experience. This is part 7 and the last of the series on tutorial on Java multi-threaded programming 2. The last part we developed our program. Let's test this program by running our app. Oops, we are getting all get likes. Let's go to remote service and see we haven't changed our print message. Let's change the print message first. And let's run again. Yeah. So the program started, get like is called, get comment, get post, get friends, and after that the result is returned. Comment, it is sorted, first is comment, then friend, then comment and like on, and then finally program terminates. So we have built our program and that's running fine. Let's see the learnings from this tutorial. So what we learned? We learned that pool of threads optimizes the multi-threading operation. Callable with future helps in thread switching for the result. Submit versus execute we saw for running task in executor. We learned to design the solution model for a problem and then implement it.